Can you guys hear me okay?
Yes.
Is that the first you've heard from me?
Yes.
All right. I was talking there for a while, so I guess they should not have old people doing this. All right. So hit me with questions.
Can you do number 3 on the exam 2? It's a capacitor of capacitance 3 microfarads has a voltage of 200 volts across it. What is the charge in coulombs on the plates of the capacitor?
So is that what you're... Is that you probably did that already. Was there some other issue?
No, I done it wrong.
Oh, okay. Okay.
I put the
All
wrong.
right. Well, you know, that's they're easy mistakes to make in there, certainly.
Thank you.
Yeah. What else?
On learning catalytics, fluids and pressures, number 14 and 15.
Okay, you're just gonna have to read them to me.
Okay. Manometer carrying mercury has one end attached to a pressurized vessel and the other open to the atmosphere. If the height difference between the two sides is 15 centimeters, what's the absolute pressure?
Is there a picture?
No.
Well, I'd have to know which side is higher. Maybe I just didn't give you enough information on that. Is that what you're getting at? So let's say the height. Let's say this side's higher, and so I've got some pressure in this gas, and this is P atmospheric, right? And the height difference. I'm sorry. Can you tell me that what that was again?
15
centimeters?
15 centimeters, yeah.
All right. And so, you know, it's sort of Pascal's principle that says, you know, at the same height in a fluid, the pressure is the same. And so that means the pressure at this point, if I call this 1, is the same thing as the pressure at this point, which I call maybe 2, right? And so that means if these two guys are the same height, that means the pressure in here, right? The pressure in a gas it doesn't matter about the depth because gases have such a low density. And so the pressure here is the same thing as the pressure here. And so if I want to get the pressure inside here, I just have to figure out what the pressure is right here. And that's just the pressure at the top. So P2 is equal to P atmosphere plus rho GH, right? And so that's P atmospheric plus the density of mercury, which is 13,000 something kilograms per cubic meter times 10 meters per second squared times 0.15 meters. I'm not positive that's the density.
It'll work.
Does that get you pretty close? Is that one of the choices? So that's how you do these manometer problems, right? You're generally wanting to know basically what the pressure is at the top of one side of the manometer, right? It's got some kind of fluid in here, right? And so, because there's no variation in pressure with height in the gas, or not an appreciable one, then it ends up being the height difference in the two columns really gives you the pressure difference between the two tops. And so that's what you're doing. You're saying, look, the difference between the two is this, and so this one is atmospheric plus that difference.
Thank you.
Yeah, does that come out to one of the choices?
Let me check.
All right. And then you have to tell me what the second problem was.
I don't think it comes out to the answer, but I think I understand the concept.
Okay.
Number 15 says, at what speed does water leave a hole at the bottom of a dam that is 15 meters high?
So this is a Bernoulli problem. Right. So the water's leaving here. And so once again, we sort of identify 2 points. Here we're identifying the top of the fluid again. And here maybe we're going to talk about the fluid that's leaving. Right. And so Bernoulli's principle says that this quantity, the pressure plus 1/2 rho V squared plus rho GH, is a constant. And that means that P1 plus 1/2 rho V1 squared plus rho GH1 is equal to the same thing at point 2. And so you have to maybe have a little experience with these. We talked about these before. So since both of these are by the atmosphere, that is to say, this water is shot out into the atmosphere and it's assumed to be a thin stream, and this is at the top, the two pressures are the same, actually, in this case. And so if you're looking at, so there are a couple other things you can say. V1 is 0, because it's just the speed of the water at the top. And hopefully if this is a small hole, it's not draining out super fast. So it's not like the water is moving really quickly at the top. And so this guy is 0. And so then what you get, I think you're asking for V2, right? The speed coming out.
Yes.
Yeah. And so I'm left with 3 terms, this one, and this one. And so I'm gonna move this one over to the other side, and I'm gonna say rho G H1 minus rho G H2 is equal to 1/2 rho V2 squared, where V2 is the thing I'm after, right? Everybody's got a rho, and so I can cancel all the rows. And this just becomes G times H2 minus H1 is equal to 1/2 V squared, V2 squared. And so V2 is equal to the square root of 2G times H2 minus H1. Right, but that's just H2 minus, H1 minus H2. I got this, I'm sorry. H1 minus H2, right? It was 1 minus 2. 1 minus 2. It's the height of the top minus the height of the bottom. Right. And so what did you say it was 15 meters?
Yes, 15 meters.
And so it's 2 times 10 meters per second squared times 15 meters. Right. And so it's 300, right? So it's like 17.3 or something like that meters per second. Something like that.
Yeah.
It's the
Yep,
same,
and that's the answer.
yeah, it's the same thing you would get if you just dropped a ball off of here, how fast it would be going by the time it got to this point. This is really just a conservation of energy type equation. And so it just works for fluids instead of, you know, sort of projectile type objects that we're used to.
So thank you.
Oh, you bet. Get all in there for a second at least. What else?
I have one from the first exam we took.
Yeah, okay.
It's a wing of area 10 meters squared has air flowing at 40 meters per second over it and 38 meters per second under it. What is the net upward force on the wing?
I think I did this one in yesterday's video.
Okay.
But let me just,
able to be at
so I'll do it quickly. How about that? I'll just talk about it for a second. It's the same equation. So you asked it in a timely way. Let me just, so here's the idea with that one. So the way wings work, old style wings, is they're flat on the bottom and curved on the top. And they do that so that the air is forced to travel a longer distance over the top than over the bottom. And because air has inertia, it kind of starts here and ends here. And so over the top, it travels a longer distance. So it's got to get there in a faster time. And so typically you get a little lift off of that. Most planes don't get that much lift off of them. But so again, this is a Bernoulli's problem. And so we can identify the two positions. I don't know, I'll call this one 2 and this one 1. And we say P1 plus 1/2 rho V1 squared plus rho G H1 equals P2 plus 1/2 rho V2 squared plus rho G H2. And again, there are a few things you sort of have to just have a little experience with. It's like I was saying with the manometer problem we did. You don't have to worry about variation in pressure with height in a gas. It's really only in a liquid. Gases' densities are 1,000 times smaller. And so the rho GH number is usually negligibly small, particularly since the height difference is really small here across the height of a wing. And so you can just drop those two guys out. What we're after in this, right, it said the area is 10 square meters, and we're looking for the net force on the wing. And so we're gonna have, if you look at these two equations, since the velocity is higher on this side and lower on this side, that means the pressure, because of Bernoulli's principle, the pressure is gonna have to be lower on this side and higher on this side because they have to add up to the same thing. And so if this term is bigger than this term, then this term has to be bigger than that term. And that's what gives you, so you get P1 is greater than P2, where this is P2 up here. That's what gives you a net upward force. And so the force going up is just equal to the pressure difference times the area. That's the net upward force. And so I can evaluate that. P1 minus P2, right, is the net upward force. It's equal to 1/2 rho V2 squared minus 1/2 rho V1 squared. And so that's equal to 1/2 rho times V2 squared minus V1 squared. Right. And so this is the pressure difference. I don't even need to be able to evaluate each of these individually. I just need to know the difference because it's their difference that produces the force. And so this is 1/2 times 1.29 kilograms per cubic meter. And we did this last time, and I can't remember what the number is. So 40 squared is 1,600. I think it's 1,600 meters squared over second squared minus, I think 38 squared is like 1,444. 44 meters squared over second squared. And so this is like 1/2 times 1.29 kilograms per cubic meter times, is that 156? .29, so 1 1/3. This is going to be about 200 divided by 2. So this is going to be about 100 pascals, which is about 100 newtons per meter squared. And so that's my pressure, and I multiply it by my area to get the force. And so I'm going to say the force is about 1,000 newtons. I kind of rushed through that. Was that Alexa? Who asked me that?
Yeah, that's good.
All right. Does that work for you? All right, what else? Somebody has to step up and ask me a question.
On electrostatics, when you ask what is the direction of an electric field 2 meters to the east of a -2 Coulomb charge, the answer is negative. So is that why it's west?
Oh gosh, that sounds. Is that a? Hopefully that was a learning catalytics question.
Yeah, it was.
Thank goodness. It sounds like I goofed there. Read that to me again. So there's a charge. What's the charge?
-2 Coulomb.
Okay. So this charge is Q equals -2 coulombs, right?
Mm-hmm.
Well, that wasn't very good. -2 coulombs. And so, did you use like north, south, east, and west?
Yeah, that's the answers.
Yeah, okay. So now I want to know the direction of the electric field where?
2 meters to the east.
3 meters?
2 meters to the east.
2 meters to the east. All right. So I'm over here. What is the direction of the electric field over here? Just on the screen here. Is it to the east, to the west, to the north, to the south? What's the direction? So if this is a negative charge, what's the direction of the electric field over here? Anybody, that's not just for Jordan. The electric field points in the direction, what?
That it would go?
A positive charge would go. I think that's what you said. So the electric field points this way. And so I would say the electric field points west. Is all it's looking for is a direction?
Yes.
So I would say the electric field points west over here. Is that, have I answered your question?
Yeah, I was just trying to find an equation, and I thought that's what it wanted, but that makes more sense.
Oh, I think it's just asking, if it's one of the questions I was asking, I just wanted to know that you recognized that this negative charge, like, I could have said above it or to the north of it or to the west of it or to the south of it, it's going to point in the opposite direction, right? Because if you go to the west, it's pointing east. If you go to the east, it's pointing west, and so on. I think that's all I was shooting for on that.
Thank you.
Yeah, you bet.
Dr. Cho,
Yeah.
you may have said this in a previous video or an email, but
Fine.
what chapters up to what chapter is going to be on the final?
So, so the ones we did were 12, 13, and 14. That's when the world was sane. and then 17, I think we got through maybe 18 right before break. And then we did 19 and 20. This was circuits and magnetism. I think we did them in backward order. And the last one I talked about was 23. And that's where I just sent you guys a little outline last night where you should know how to use Snell's law and just like what refraction and reflection are and stuff like that. And so this is most of the final.
Okay.
And so I would say there's some questions on this, but the lion's share of it is those chapters.
Okay. And then are we still required to take it at 8:30 or?
I'm going to run it from, I'm going to have it from 8 to noon.
Okay.
And I'm just going to give you like a 2-hour window in there. So you have to be done by noon.
Okay. But you could start it at 10 o'clock.
Yeah, I wouldn't.
Okay.
You can start it at 9:30.
Okay.
I mean, I wouldn't, that's just my, is there anybody who has a big problem there? Because I can open it for a larger window.
I just wasn't sure because that email that we had gotten about the test times, it was kind of confusing. So I didn't know what we were required to do.
So they, I'm sure you know, I have no power here. They tell us kind of what they want us to do, and that's what we do. And so I'm pretty sure what it said is a 4-hour window. You guys need a 4-hour window. And like, I have somebody who's working tomorrow from, I forget, 8 to 5 or something. And so I'm giving the test to that person at like 7 tomorrow night. If you have some kind of serious, I can't absolutely do it, then I can work with you on that. But they want it in, in a window around the exam time. Our exam time was 8:30 to 10:30. And so that's what I'm shooting for.
Okay, thanks.
Yep.
Dr. Trail?
Yeah.
Could you talk about Faraday's law a little bit?
Faraday's law. And so,
I have the book open if you want me to like find an equation.
I'm just trying to decide, can you give me a problem?
Yeah,
So,
that's what I meant. Not an equation.
So I mean, we can calculate the magnetic field due to a wire. Or the magnet, I mean, let me just see if I've got a book here too. I can pull up an example maybe.
Maybe like 21.3 would be a good problem.
21. Do you mean 20 problem 3? So 21 isn't on the test. We didn't do chapter 21.
Oh, okay. Sorry.
Um,
That would explain why I don't remember that.
Yeah. And where we do cover that is in lab. But I won't put that on the final. So we would have covered magnetic flux, which is, I think, what you're talking about here. And there are a few ways to apply Faraday's law. but I think, I think the kind of thing you're talking about is what we would have done in lab, and so you wouldn't see it on the final. What else? Are you guys out of questions?
Did you do problem 5 in chapter 20?
Yep. I want to hear problem 5 in chapter 20.
It's page 663 on the online. But
Oh, okay. Uh-oh. You know, I have an old edition of the book in front of me. So I bet it's not going to be the same. You may have to tell me what it is. Hang on a second. Problem 5. Can you just tell me the first few words of it?
at a given instant,
Ah, here we go. Okay. A particle with mass 5 times 10 to the minus 3 kilograms and charge of 3.5 times 10 to the minus 8 coulombs.
yes.
All right. So here's my particle, and it's got a mass. I'm gonna have to write with the blue because the black doesn't write. Its mass is 5 times 10 to the minus 3 coulombs. Well, it's kilograms. Kilograms. And its charge is 3.5 times 10 to the minus 8 coulombs. So that was its mass. And that was its charge. So it's traveling at, I'm just going to call it up, right? It's traveling with V equals 2 times 10 to the 5th meters per second in the plus y direction. So at a given instant, a particle of mass 5 times 10 to the minus 3 kilograms and charge of 3.5 times 10 to the minus 8 coulombs has a velocity with a magnitude of 2 times 10 to the 5th meter per second in the plus y direction, and is it is moving in a uniform magnetic field that has a magnitude of 0.8 Tesla and is in the minus x direction. So here I am going to have to get another marker. Here we go. So, maybe I wish I didn't put this all over on the edge, but so it's got a magnetic field going this way, which is B equals 0.8 Tesla. And so the first thing it says is what are the magnitude and direction of the magnetic force on the particle? And so does anybody know how we get the direction of the force on this particle?
You put your arm in the direction of the velocity and then point your fingers in the direction of the magnetic field.
Perfect. So I run my arm this way, and then I have to curl my finger. If I put my arm like this, I would have to turn it this way so I can curl towards the field. And then my thumb points in the direction of the force. So the force, let me try again. The force is out of the page, so to speak. It's not really a page. Right? How do I calculate the magnitude of the force? Just its value. What's the formula for that? So do you remember the force equals Q times V times B times the sine of the angle? It's called the Lorentz. It's called the Lorentz force. He was kind of Einstein's major professor, I think. And so it would just be 3.5 times 10 to the minus 8th coulombs times 2 times 10 to the 5th meters per second, right? That's Q times V times 0.8 Tesla. And the sine of, they're at 90 degrees. And so the sine of 90 degrees is 1. And so we would have to multiply all those out. So 2 times 3.5 is 7, times 0.8 is 5.6. So I think what we get here is like 5.6 times 10 to the minus 3. And that's, that would be in newtons. SI, SI, SI. So this would be in newtons.
Thank you.
Yeah, and then, you know, I think in part B it says what's the acceleration, and that's jumping all the way back to last semester. Acceleration is the force divided by the mass, and so that would be 5.6 times 10 to the minus 3 newtons divided by the mass, which is 5 times 10 to the minus 3 kilograms. And so I don't know what that is. It's like 1.1 something. 2 meters per second squared, something like that. Okay, good. I should like pay $5 a question or something.
Dr. Cho,
Yeah.
with regards to our grades, like on Canvas, it like has the practice test and stuff still as part of our grade. Will we just have to look at our transcript for our final grade?
Um, I will probably have the spreadsheet up there at some point, but it won't be soon. I've got to accumulate your lab grades, and I've got to regrade that redo on test 3.
Mm-hmm.
So I'll try to get all that information up there at some point. It'll probably be the weekend before I do that. If you have, a few people have just called me or emailed me with specific questions about where they stand, and I've tried to help them work through that. I had the thing about test 2 where I'm going to try to, not kill you with test 2. And so there's some fuzzy stuff in your grade right now. And so I think, well, you will probably see your final grade at the same time that you see all the other grades. So.
Okay, cool, thanks.
Any other questions? I don't want to just stop you, but. All right. Well, I'll put this recording up. I put the other recordings are up on my YouTube thing. And so I think I put links to them in the announcements. And I'll put this one up there too. And my advice to you all is get some sleep.
Dr. If I come across anything I need help on, can I text you?
Yeah.
Awesome.
Yeah, you can.
Thank you.
I'm not very functional after about 9.
Okay.
But before that, you probably get an answer out of me.
Okay.
Right.
Thank you.
Yep. Have a good night, guys.
Thanks.
You too. Thank you.
Thank you.